Good evening, and welcome to students and to guests. I am Professor Namdi Ele, Head of School of Architecture and Planning at the University of the Witwatersrand. We are pleased to be co-hosting this prestigious international event with the Italian Cultural Institute and the Embassy of Italy. We welcome His Excellency Ambassador Paolo Cucilli. Your Excellency, please forgive me if I do not say your name correctly, of the Italian Embassy, as well as this evening's presenters who will be speaking to us from Italy. Welcome to Irene Giglio. Irene, welcome. Please forgive me if I'm not saying the name correctly. Of Mario Cucina Architects, and Emiliano Cecchini, CEO of Off-Grid Box. We would like to thank Daniela Bonino at the Italian Cultural Institute for her help with the coordination of this event, as well as her colleagues at the Cultural Institute and the Italian Embassy, who have also been involved in the organization of tonight's activities. From the School of Architecture and Planning, our thanks go to Patricia Theron for her work coordinating this event, and to Doug Bauman, our exhibition curator, who has worked with hard to build the online exhibition. We would have hosted the Italian Design Day at the school earlier in May of this year. However, due to the pandemic, we had to alter these plans. The work of Mario Cucinella architects would have been exhibited in our school gallery, but now it is available to everyone around the world, and we invite you to take a virtual walkthrough after the presentation. Briefly, some logistical matters as we proceed. Please ensure that your microphone is muted to improve general audibility throughout the presentations when the microphone is handed to the key presenter. For those who are guests and are looking for continuing professional development points, please take note of the CPD passphrase, which is projected on the screen. The CPD forms can be completed online on our website until 8 p.m. We will hold an open question and answer session at the end of the presentations. Also, please note that the chat function is only accessible to students and staff of WITS. Our apologies for that. The raised hand function is accessible to everyone, and you are all invited to use this function and to ask questions when the time comes for open discussion. The Italian Day is an initiative that is held all over the world, and we are proud to be involved in South Africa edition. The fourth edition this year is themed Drawing the Future: Development, Innovation, Sustainability. The Italian Day Design features events celebrating Italian design and its creativity and innovation potential in different fields, cultural and economics. It is a world leader in the fields of design, architecture, and urbanism, and in creative economics and knowledge industries. We hope that in the future there will be a continuance of dialogue to enrich cultural and perspectives on the design. And now, please, I would like to introduce the Italian ambassador, His Excellency Paolo Cuccioli of the Embassy of the Italian, to address the audience. Your Excellency, the floor is to you, sir. Welcome.
Thank you so much, Professor, for your kind words, and be reassured that in Italy they pronounce on average my family name in much less accurate terms. So I'm grateful for this. I'm grateful for the hospitality that the School of Architecture Planning of the University of Witwatersrand offers us. I wish really I could have been in person with you, with our guests from Italy, but we are living troubled times. So we will keep this pleasure for, I hope, a future not too far. Professor, you made my task much easier because you have said basically everything a good ambassador of Italy should have said. With only one omission in the title of the Italian Design Day, which is indeed Drawing the Future, Development, Innovation, Sustainability, and Beauty, which is something that it is very dear to both Italians and South Africans. Um, I'm very glad to take the floor today with you, and on my side, to a warm welcome to all our guests in Italy and to all our friends and followers in South Africa. I think that the times we are living make this event particularly relevant because of the unprecedented challenge that the pandemic in the immediate, the climate change, and the very concerning developments in our environment pose to us all. We tend to look at those historic phenomena as something that should be left to the study and to the attention of scientists, virologists, and so on. And we tend to forget too easily the unprecedented challenge that those phenomena pose to us all in terms of the way we live our public and our private space. And here, the theme of the Italian Design Day and the theme of the presentation of architect Irene Giglio, whom I warmly salute, though from a distance, come into play with generally the understanding we tend to have of design as perhaps something that pertains more to the way we shape our private houses, while on the contrary, it affects deeply our public urban spaces, the way we live in it, the way we think about those spaces, and more broadly, the kind of urban living we are pushed to live, especially in this time of transition. Um, I was really seriously astonished in going through the online exhibition of Mario Cucinella architect works. To me, and I come back to the title of the Italian Design Day, it was really a beautiful voyage in the future, both in terms of the visual beauty of their works. And I really invite all those who are participating in this event to take a look at the solutions that Mario Cucinella architect envisaged for the seat of the Autorité Poste et Télécommunications in Algiers. And they're a beautiful building shaped following the design of the desert dune, or the university campus of Berenguer in Morocco. And you would see the buildings modeled out of the cactus of the deserts. The Nkrumah Presidential Library in Akosombo on the banks of the Volta Dam in Ghana. And in all those instances, you would see how the design perfectly blends into the environment, both in terms of the look of the buildings as well as the innovative solutions that have been envisaged in terms of as far as the sustainable management of energy sources are concerned, water, electricity, wind, all the natural elements that make the richness of our planets and of our lives are there. And I'm particularly glad that there will be the possibility of hearing the Italian company of Gridbox to present their innovative solutions to use solar energy and to purify waters, among other things. Finally, because I don't want to deprive all the participants of the pleasure of watching the art exhibition and listening to the presentation of our distinguished guests, um, I was really amazed in looking at the solutions that Mario Cucinella, architect, envisaged for the first urban living designed and realized with three-dimensional printing. And that brings us straight into the fourth industrial revolutions. And that was done in Italy, not yet in Africa, but I think it was a very inspiring architectural masterpiece as well. So I will keep myself short. I look really forward to the presentation of our guest speakers this afternoon. I look forward to welcoming them in person here in South Africa. I hope that this cooperation with Vateran's School of Architecture Planning may start today and continue fruitfully in the future, and that this event today may open the way for an even wider presence of Italian designers and architects and companies realizing the innovative designs of our architects in South Africa as soon as possible. Thank you so much to everybody, and I look forward to the presentations and to the debate. Thank you.
Thank you, Your Excellency. You are very generous. You make people at ease. Very kind of you for the kind words. And now, dear colleagues, I would like to introduce tonight's speaker, Irene Giglio. Please forgive me if I'm not saying the name right. She is an architect who has specialized in integrated environmental design. She has a master's degree in architecture focusing on sustainable environmental design from the Architectural Association School in London. She is the international account manager at Mario Cucinella Architects and a return lecturer and external reviewer at the AA. Giglio is also a visiting professor in many international universities, and she regularly delivers lectures and presents at conferences all around the world. The topic of tonight's lecture and the theme of the online exhibition is Architecture in Time of Climate Change. In this presentation, Giglio considers that global changes presents creative opportunities that can lead to a brand new architectural language. Mario Cucinella Architects has done extensive research on elements we can derive from vernacular knowledge and on the adaptive capacities of plants and able to create deep empathy with their surroundings. The projects that will be presented this evening have been selected from those located in Africa, in line with what His Excellency has presented to us. That's an outcome of well-respected and chosen gift for us tonight. Like the ambassador said, it would have been such a pleasure to be in person to share this moment, but we postpone it to the future. Without much ado, the floor is over to you, Architect Giglio. Thank you. Over.
Thanks a lot. Thanks. Can you hear me? Yeah, cool. Good afternoon, everyone. It's a pleasure to be here with you today, remotely, sadly, but as you said, gonna be happy to be and meet you in person as soon as possible. And today we're gonna deal with one of the, let's say, most timeless topics, but nowadays also one of the most topical ones, because architects today have been called, and all the members of the architecture and design community, to design and invent for a world that will never be quite the same as before. And the reason why it won't be quite the same as before is twofold. On the one hand, we have an evident pandemic that is affecting the whole world. On the other hand, we have probably a less evident but equally compelling problem, that is climate change, that we've been dealing with for over a few decades right now. And that is something that is also changing the world we live in a way that we cannot yet fully imagine. So today we're gonna deal with how these problems and these challenges can be seen as creative opportunities and therefore lead to a proper revolution in the way we design. So I have just prepared a few slides to share with you. Let me see if I manage to share my screen with you. Wait. Wait, I just have to close something here. Just give me a second, something's not working on my side.
Take your time, no rush.
Okay, that's it. Cool, found it. Can you see it?
Yes, yes, very clear. Colleagues, can you see?
Great. Okay. So just a few words to give you a little bit of context of our firm. As you said, I'm Irene Giglio. I'm architect and international account manager at Mario Cucinella Architects, which is a firm that is based in Bologna, Milan, and New York, as we're going to see in a while. But we have carried out research and projects all over the world. So our projects just touch all the 5 continents. And of course, we have plenty in Italy. And as I said, we are based in Bologna, Milan, because we have a lot of building sites in the north of Italy, and we have a studio in New York. I just wanted you to quickly glimpse at the place where we work. Here's a few pictures of our atelier in Bologna that is, as you see, immersed in nature. You'll understand why in a while. I would say it's a rich and stimulating, and I should say quite young, actually, community of about 100 people, led by our founder and chief architect, Mario Cucinella. And here we are, quite a few years ago, but that's the whole team. So now let's go with our main topic. I'll try to be accurate, but not boring, I promise. Let me just illustrate very quickly a few facts concerning climate change that, if looked one after the other, can give a, let's say, complete picture of the situation. So first fact, 2016, as you see, was the warmest year on record, with global averages almost 1 degree Celsius warmer than the mid-20th century averages. And besides, as you see, 17 of the 18 warmest years have occurred after 2000. Fact 2, as you probably know, the Earth's climate has changed many times throughout history due to a variety of causes. So for instance, there might be a volcanic eruption that releases a lot of gases to the atmosphere, and all of a sudden it changes the way that sun rays are reflected. It's not very accurate maybe, but that definitely gives the idea, and so forth. However, this is the first time that the global warming trend cannot be explained through natural processes only, but it's most likely that it is the result of human activity. So the third fact is that you might have heard about the Paris Agreement that back in 2015 called for holding warming well below 2 degrees Celsius, 1.5 ideally. But let's take a look at this graph that shows CO2 emissions for each year until 2012 and then projections or scenarios for the following years. The blue line, which is the most optimistic case, is based on a drastic reduction of CO2 emissions and would be the only one to comply if you see what happens in 2100 with the 2 degrees Celsius of warming that was, let's see, foreseen by the Paris Agreement. The red line instead is what would happen if we go on a business as usual moment, meaning that we do what we've always done. And now we can say, so now it's 2020, so we can draw some conclusions, and we are exactly on the red line. So if we don't do anything, temperatures are going to increase by 6 degrees Celsius or even more, because that's like from 6 onward. And if you see that the damage does not start at 2 degrees Celsius as the Paris Agreement had foreseen, but it's already here. So glaciers are melting, storms are getting stronger, plenty of animal species are about to disappear forever. But that's more, because it has to be highlighted that climate change is not uniform across the globe. So global warming is not uniform. This is due to physics, basically, because the globe is divided into 2 hemispheres, with the northern one is called the land hemisphere because it has more land covered surfaces than the southern one, and the southern one called the oceans hemisphere. So as you know, it's much easier, or better, it requires way less energy to heat up a volume of earth than the same volume of water or ocean, because oceans dissipate heat deeper. And the result is that it is much easier to heat up the northern hemisphere, let's say, than the southern one. So 2 degrees Celsius of global warming might mean 1 degree Celsius somewhere in the southern hemisphere, but over 6 degrees somewhere else in the northern one already. And this is not all, because when we deal with climate change, there's a term that is climate change vulnerability, that deals with how countries can deal with the consequences of climate change. And all the highly vulnerable countries are just located in Africa, in this continent. And if you think that almost 50% of the world population increase that is expected by 2100, which is incredible because it means 3.4 billion of people more if compared to 2019, will be concentrated in this very continent, well, that's like a quite worrying picture of the situation. So now, why shall we, let's say, pay particular attention to the building sector in this context when we deal with climate change? Because if today the Earth carries 162.8 billion of built square meters that were built throughout the whole history of the world, there will be 2.7 billion more in just 6 years from now, of which 50% are going to be concentrated in China only. And most surprisingly, and I should say most shocking news is that there's going to be 230 billions more by 2060. And indeed, the construction sector is accountable for the production of 40% of global CO2 emissions. So if we really want to mitigate emissions, we have first of all to radically change the way we build, because we need to be able to give everyone a house, even when the population is gonna increase, but we have to build them in a fully different way, in a deeply different way. And I mean radically. However, if you take a look at this timeline, you can understand how we were used to build buildings even before the first industrial revolution, so even before the 19th century, when energy was actually not available. So we had buildings, we had everything, but we could do somehow without energy. So how was that possible? And above all, can we build a bridge with our past and learn something on how to on how to build buildings for our future by learning from our past when we were building them without energy? Probably yes, but I'll be very quick in this. That's a timeline that we have developed. Sorry, it's in Italian, about sustainability. And there's a lot that was developed about sustainability already before the first industrial revolution. So I won't be long on this. It's just for you to understand how many things and ideas were circulating even before sustainability and climate change was actually a global issue. So now, just a second, can you see my slides?
Yes,
Oh,
yes, very, yes, thank you.
My PC is just black. Okay. So, as I was saying, as humans, we had an incredibly rich knowledge. It's called vernacular knowledge because we were building houses and dwellings and homes that were deeply different according to the latitude and the climatic locations in which they were placed. So we have a lot to look if we look at history and how we were building before. So for instance, the need for ventilation in desertic climate like the one they have in Iran, with extremely high daily temperature swings and therefore a lot of need for night flushing, has given birth to these landscapes that are just studied with these towers that are called the wind catchers, and that make this landscape absolutely unique. Or for instance, in very hot and humid climate that highly benefit from the shading and ground cooling and evapotranspiration, we could and we can actually find these the so-called step wells that provide comfortable microclimates with a temperature reduction between the upper and the lower part of even 30 degrees Celsius. Or again, coming back to desertic climate, the need for a high thermal mass has shaped these mud huts in Cameroon, whose external surface was also sculpted and carved with geometries that are able to self-shade the whole envelope. And there are plenty of other examples all around the world that show an incredible richness in shapes and behaviors and geometries that we should definitely take a look at when building responsive buildings for different climates. But that's not all, because that's another point of view that might be interesting and that Mario Cucinella Architects has been carrying an extensive research about in the last years, is that there's something that we can definitely learn from an even more hidden source, let's say. And in fact, there is something that's just like buildings cannot move. And still it has found over the millennia a way to thrive in every possible climate, which is vegetation. It has been said, and there are a lot of scientists that are currently carrying out a lot of research on this, that plants are actually intelligent. And indeed, they have demonstrated an incredible ability to effectively adapt to almost any condition. And in fact, plants have been on Earth for like 500 millions of years, while men only for 250,000. And also plants have all 5 senses, they can definitely solve problems. So the result, once again, is an incredible variety of shapes, geometry, components, behaviors that radically change with climate and latitude above the globe, all around the globe. And you see how they actually change all these characteristics as we go from a very cold climate to a very hot one. Now, given that we have a lot to learn from all around, from vernacular architecture, from our past, to the plants intelligent all around, but of course our work is not just copy pasting what we have around or what has been done in the past. What should our attitude be like? So that's the question. How can we actually make building look or better behave way more like plants, or take a look at how they were built in the past and be responsive to climate, instead of having the glazed skyscrapers or boxes that populate all the metropolitan areas of our cities. So I will try to illustrate our own approach through a selection of projects that has been said were selected from the African case studies, that are able, in our opinion, to showcase our aptitude in making innovative buildings that arise from what they have all around, and they can actually read the context in which they are located and express all their characteristics and creativity and beauty according to the location for which they have been conceived. Let's start. As I said, they're all mainly African projects, but this one I believe is particularly interested because it's a prototype. So it was actually conceived to fit it with almost any climate, and we're gonna see how it does adapt to each climate. And it's called Tekla, and it was mentioned before. It just changes shape, skin, orientation, materials, and so forth according to the position on our globe. As we said, it's an innovative, it's the first one. It's a 3D printed dwelling prototype made using entirely local earth, local soil. It was conceived especially for highly vulnerable contexts, but it can be adapted to almost any condition. So now I'll be very quick on this. You all know the, let's say, benefits of using 3D printing, because the times are much shorter. It takes 24 to 48 hours to complete an entire 50 square meters house, for instance. Let's say we're dealing with concrete in this case. It has lower costs. It's much safer for people working in the building site. It has lower emissions because, of course, the building site lasts less, so it just consumes less energy. There's virtually no waste, because when you print something, the printer knows exactly the amount of material that is going to be needed, so there's no waste during the process. And also the result, the design, is extremely flexible, and we're going to see what it means. But the real revolution does not lie in our idea of using 3D printers to build houses, because 3D printing is innovative. It's the future, but it's been around for quite a few years right now. But the real revolution lies in the fact that we have chosen to use earth as the main building material, because a lot of people are now making a lot of research with 3D printing concrete, for instance, but we thought that was not enough. It was not enough sustainable, because concrete needs to be disassembled, needs to be sent to the landfill once the whole life cycle of the building is over, while earth, and here's where the deep innovation lies, earth can actually just go back to the soil. So once the life cycle of the house is over, the whole envelope just goes back to the soil in a real and full circular economic model, in which buildings can finally leave no footprint on our planet, which is the real revolution of this project. So as I said, Tekla can actually change in all its part according to climate. And one of the most interesting aspects of this adaptation is probably its own envelope. So in fact, the traditional building technologies, we all know the bricks and mortar ones, are quite rigid in a way. So besides having a layer of insulation or ventilation in between the bricks, there is not much more one can actually do to adapt to different climatic conditions. While 3D printing, on the contrary, allows to create, let's say, virtually any shape, and therefore envelopes can be fully tailored to specific local conditions. So this is a section of the wall, might be not recognizable immediately. Then we have developed with two parametric sinusoid, whose frequency, width, and thickness can vary with the external temperature, daily swing, and humidity. And this gives birth to a variety of very different envelopes that actually change with latitude. So you see we have a graph, we have temperature on the right, we have humidity on the left, and you see that if we have more and more thermal mass, for instance, which means that the period of the sinusoid is smaller, so you have more mass actually for higher temperatures, and increased ventilation for where humidity needs to be flushed away, so for more humid climate. And this is a very interesting pattern. So actually, according to external condition, you can have a kind of brick which is fully tailored for the purpose. So as I said, building can change in many ways based on different data, their input data. And that, besides climate, can concern, for instance, the type of users, their number, their needs, their aspiration to define not only the envelope, but also the configuration of the single dwelling and of a possible settlement. So you see here that starting from where the dwelling would be and who the users would be, you come across a variety of choices that you can make. You have the location data, you have a climate that comes out, materials, because they need to be local materials. So according to the location, you would also have different additives, for instance, to local soil. You have different resources, so you might have more solar, more wind energy, and so forth, more geothermal energy, more tidal energy, or like other examples. And from all these, you have a set of strategies that go into the definition of the envelope, which is what we said before. At the same time, we have a set of information about the users that can come from population data, you have benchmark, and together with the location data, they come to a dwelling configuration, and altogether they allow us to understand what's the most suitable settlement configuration that comes from people needs and aspiration, but also from climatic data, as we'll see in a while. So in particular, what we did was starting from a self-supporting shape, because it needs to be printed layer after layer. So the geometry is just pushed and pulled and opened and printed and crumpled to respond to a series of different conditions, as we'll see in a while. This means, for instance, that for very cold climate, what we have is a very compact geometry, just like an igloo. So it just really looks at what a vernacular architecture has developed in the place, where the climate is rigid and less dispersion is needed, with the door that is always oriented on this other side with respect to prevailing cold winds, and the glazed element that is optimized to allow and welcome low sun angles penetration. And of course, the result is also a very compact settlement with dwellings that always face some protected spots. So these spots are protected from wind, but are accessible to sun, and therefore they are kind of comfortable outdoor pockets. Another solution, that I've also added a few images to see what it just looks like. Another possibility is that, for instance, for very humid climate where thermal mass, because they're all made of earth, so they have a lot of thermal mass, but for humid climate, humidity just needs to be flushed away. The dwelling becomes more elongated, let's say, in both directions, so that you can have both cross ventilation and chimney effect to flush even more effectively the envelopes. And the master plan, of course, also allow for fresh breezes, penetration, and so forth. And another example would be the one that we have developed for arid climate, for instance, that we have imagined. I'm gonna go a bit fast just because we have a lot to talk about, but we can come back if you have questions after that. We have imagined an underground dwelling for hot and arid climates like the ones that populate the desert, to benefit from shading and thermal mass with buildings that are just carved within the earth. So what you have is a kind of protected and shaded spot, which is almost fully underground. There's a lot of these examples in the vernacular architecture from the northern part of Africa. And this is the result. So very massive and very shaded living places that are almost underground. And the last case study was developed for our own climate. So let's say northern Italian one. And we actually have a temperate climate. We have hot and cold seasons to cope with. And this is the result because we have a compact, openable spaces that are oriented to be protected from summer sun rays while also welcoming the winter low ones. At the same time, we are protected from cold wind breezes during the winter while we welcome the fresh ones during spring and summer. And the village is, of course, conceived to be fully off-grid, as you see, so it just takes advantage of all conditions to, thrive without being actually connected to the energy, the water, and the waste grids. That's a few examples how it just feels like to live in an earthen 3D printed dwelling. And we believe these images are quite meaningful, but actually this is not a dream, like, 3D printed mud house, because in fact we are actually on site with this prototype. Let me go to a few pictures of the building site. Yeah, it's almost over actually. News and pictures are coming soon by the end of the year, most probably, but we believe it's a project that, it concerns a lot of things that are going on nowadays. It concerns the latest technologies. It concerns the fact that if you take a look at these pictures, these are just the stages of the building site. So here's how it's going to be built. You have printers. The metallic ones are the printers. They have a robotic arm to print them all. It was probably more clear here. You see how it works. Then you have life in Tekla village. And then once Tekla is not useful anymore, because we always have to think about what happens once the buildings are not used anymore. Because nowadays we've always designed for buildings that we thought were going to last forever, which is not the case. They need to be dismantled, disassembled. Their waste has to be sent to landfill. It's often very toxic. While in this case, once the use is over, Tekla just goes back to the soil and nature can just come over and thrive again. So the earth is fully biodegradable. So actually the earth is just reabsorbed by the environment. But now let's come to the African projects that were actually mentioned before. This is the Berngir University campus in Morocco. And as we said before, well, there's a lot to say about the master planning proposals, for instance, but to come to try to focus on other aspects that are the one we were dealing before. What could we actually learn from plants? As it was said, in this specific case, we tried to learn something from probably the most famous type of local plant, which is the cactus. So as you see, in order to survive in the hot desert where cacti actually thrive, they have developed a jagged outer shape that is able to effectively keep most of the plant shaded throughout the whole year. So you see a picture and you see how a picture with a thermal camera looks like. So the blue color means that temperatures are way lower, and the red ones are, of course, the highest ones. So as you see here, what we have is most of the outer surface of the cactus shaded, and therefore, even if temperatures outside are as high as possible, it is shaded, and it's shaded by its own skin. So what we've tried to do is to, starting from these very natural and simple geometric principles, to develop a highly intelligent envelope with internal shaded courtyards and an envelope that is made by all these pieces that are able, with very simple geometries that are highly optimized and oriented with solar sun angles, the most critical ones, to be fully self-shaded. So all the glazed are shaded for 80% of the year by the geometry of the envelope itself. And of course, this is instead taken from local vernacular architecture of the dense cities that have thrived in the desert over the years. Also, this building is all placed around a central courtyard that allows for internal ventilation, so that all the spaces that face the courtyards can have cross ventilation and then stack ventilation through the courtyard. But also it has water and vegetation that help, especially in very arid climates, with evapotranspiration. So the second example has instead been built already quite a few years ago in Ghana, and it arises from local, natural and man-made patterns especially, but also on the assumption that what is most needed in such climate is definitely shading. So by shading only, we're able to cut the energy demand of a building by 40%, which is an incredible amount of energy. And this coupled with the very high thermal mass that is offered by concrete. So we've decided to have a very massive concrete structure and these very thick concrete slabs that help with shading, but also with thermal mass. We can actually achieve an incredibly good thermal performance. And as you see, this is coupled with ventilation again. Once again, we have a central courtyard that helps, as you see, with cross ventilation, but also with daylight penetration throughout all the floors, and also with an even daylight distribution inside all around. And this is what it looks like. It's a maquette, actually, a maquette again that shows the complexity of the assembly operation of these very big pieces that have gone through an equally complex optimization process that I won't explain today, but that I believe is meaningful to understand that nature must be read, understood, interpreted, and its rules, let's say, recreated to give birth to a consistent piece of architecture. So in these cases, for instance, the grid might look very untidy somehow, but actually all the pieces are studied and optimized to have a maximum number of 5 different pieces, so that it was much easier to produce them. And this is the central courtyard where all the rooms and spaces are just faced with. Another project that was mentioned before, and this is probably one of the most iconic examples from our African showcase. It's also on site, so we're building it, and it's inspired to the dunes. You see how the shape is quite explicit, but also to these elements. They're called the turat. They are found in the desert, and actually there are some in the south of Italy as well. And they were actually built to protect the cultivated areas from the sandy, hot winds coming from the desert. And at the same time, thanks to the other side of this geometry, it was actually able to allow for the cold night winds condensation on this side, so that it could just let droplets of water on this side that could be collected in a tank underneath. So they were actually a very clever yet extremely simple and poor bioclimatic devices. So what we've done is exactly the same in a more, let's say, complex way, because we have a more complex geometry, we have a more complex facade, which is inspired to very local architectures and geometries, and in which we have a structural shell, we have the different floors, we have an inner skin, an oasis, and a lot of passive strategies all around that we're gonna see in a while. So what happens is just that we have just like in the Turat, this shape, very aerodynamic shape, protects the whole building, if you see it on the left, from warm day winds that come from the sea and are very hot and that are not welcomed inside the building, while the night wind that are fresher and come from the mountain are just welcomed thanks to the more open shape on this side. Besides, while they approach the building, they just have to pass through the oasis, which, as I said before, through evapotranspiration, which is given by the plants and by the water, even increases the freshness of this water before it just enters the building. And while it enters the building, it meets this canon lumière, which is an element that just crosses through the whole building that allows, as you see, daylight penetration and also allows for stack effect, so that this fresh air can actually cross the whole building and just be pushed out at the top of this element. So this is the effect that we have on the one side, where you see it's more opened. You have these terraces that are protected and shaded by these elements that carry PV panels and elements. And on the other side, that maybe I have not put any render from this side, maybe the first one, you see how this shape is more closed and aerodynamic and allows for wind protection. As you see, the skin, I haven't put any slide on this, but it's again perforated, and you see how these panels and elements are placed, and they are placed according to the internal function. So which one needs more shading, more daylight, which one is most occupied, and so forth. So it's a very complex engine, let's say, because it has a very complex skin. It has 3 layers of skin. It has a very complex PV facade on the other side, but it's inspired to very simple principles that come from the environment all around, as we saw. So now another project that was also mentioned before is the Nkrumah Library, that was designed for a local, let's say, the daughter of Nkrumah. And it is an interesting building because it's made of very open and flexible circular plans, where you have, as you see, all the functions located on this kind of very overhanging slabs. You have courtyards piercing the envelope. And as you see, once again, one of the key aspects of these is shading. So all the plants are able to create these overhangs that just shade these circular and spiral terraces that flow all around the internal spaces, and that just constitute an extension of such pieces. And as you see, a series of elements that you see here, like a curved one, also help with shading the glazing elements all around, but also become very iconic elements of this building. So we've called that a library, but it's actually more than a library because it has a lot of functions all around. As I said, it's open, it's a very layered space, so the functions just flow one into the other all around this very interesting courtyard that we're gonna see it in a few renders, in a few slides in a render. But it's not only the very heart of the building in terms of the way it just allows all the spaces to overlook each other through this vegetation, but it's also the heart of the bioclimatic functioning of this building, because we have natural ventilation through the external glazed elements of the building that are just pushed outside through stack effect throughout the upper part of the building. And here what the courtyard looks like, you see how all the different ramps and places just overlook each other and create this very layered space. So the last project, I think is the last one. The last project is not an Mario Cucinella Architects project, it's an SOS project. So SOS is a School of Sustainability, that is a postgraduate school that was very, let's say, Mario Cucinella, which is the chief architect and founder of Mario Cucinella Architects, deeply wanted to allow young architects or young professionals, just once they've done with studying architecture, to be helped on their way to solve the sustainability and, you know, climate change related problems. So he has found this school. It's called SOS. It's based in Bologna. So it's really embedded inside our firm. And I'm saying this because the students are just called to, you know, solve practical problem. It's not an academic work. They're not faced with, you know, simple research. They have to face real problems, the real problems that we face every day in our firm. So what I'm showing was one of the example of one of the projects they have developed together with us, because they always carry out projects in collaboration with the architects of the firm, and that's where I think the experience lies. And this is the Tambacounda Hospital in Senegal. It was a very interesting project. It was for no-profit. It was a no-profit one. And after, you know, carrying out an extensive research on what it means to, you know, we have a lot of numbers to say what it means to live in Africa, to go to the hospital in Africa, because it's quite far, especially in Senegal, from what we think going to the hospital would look like. They once again have just looked around to understand what vernacular architecture has to teach us, as we said. So we've looked at how the traditional villages are aggregated to each other. You see these very circular shapes. You have aggregations that are again circular, and this is due to climatic, of course, necessities, but also to, you know, the kind of society that we have that they have, in which all the families and communities are very bond together and they collaborate even in raising children and so forth. So as I said, what we had to do was a maternity extension to an existing hospital. So this is all the research that was carried out to understand which were the functions, how each function, the birth unit, the neonatal unit, and so forth, had to be linked one to the other. Because as you know, in hospitals, the paths are everything. So how you get from one room to the other without intersecting other paths, that might be the dirty path and so forth. So, you know, understanding how the layout would be was quite meaningful. And the result at the end was that, so you can see here how there's this circular element that are already existing, and you see 3 more in the lower part of the drawing. What we had to do was to create a connection between 2 of them, so refurbishing each of the module and creating a connection. And what we've decided to do was to add these kind of roofs that are not only iconic, so they do not only help to make this place a recognizable one for the whole community, but also help with their bioclimatic behavior. We're going to see it in a while. And we also had this very organic path all around these 2 elements that allows them to connect, but also gives to these very hot outdoor spaces a shaded path to walk or to wait, because there are no waiting rooms or spaces in this kind of hospital. So we've just provided one. Again, paths are actually very important, and this is the final result. As you see, there might be a section. These roofs help to actually hide the chimneys that help with natural ventilation. As you know, there are a lot of spaces that needs to be ventilated a lot, especially in hospitals and especially in very hot climate. They do not have, of course, air conditioning. So to allow for internal comfort, we had to work with natural ventilation and shading and everything the climate had to give, without recurring to artificial sources of energy. And once again, the whole building was placed and located all around courtyards, our vegetated courtyard, and once again allow for the creation of waiting spaces that are not only beautiful, you know, in a hospital, beauty is essential because it has a healing power, and that's something we've dealt with quite a lot of hospitals. Now I'm dealing with African projects, so I didn't exactly go in depth with the topic, but we do strongly believe that beauty has a healing power for people. So healing places needs to be beautiful and to offer places to somehow escape from the illness of which one is affected. And once again, it's not only about having beautiful places and having vegetation, but it's also about having bioclimatic condition, a microclimate that is favorable. So the waiting room is shaded, it's ventilated, you have vegetation that goes through evapotranspiration and so forth. So thanks a lot. I'm looking forward to the questions at the end.
Thank you.
I hope it was enough time.
Thank you very much. Thank you very much. Before we start accepting questions, there is one more presentation, and it will be good to have that presentation, and then we can proceed with question and answers. It is going to be coming from the principal of Cucinelli, of the architecture firm Cucinelli Architects, and it is coming to be one of our main presentations by Emiliano Cecchini, the CEO of Off-Grid Box. And it is going to be titled From Mitigation to Adaptation. Without much ado, I would like to invite architect Cecchini to take over. Thank you very much.
I think he has the microphone off.
Aha.
Hello? Can you hear me?
Hello. Yes, we can hear you. Thank you.
Okay, very good. So yeah, I was saying I'm reaching out from Italy at the moment, and I've been knowing Mario Cucinella for a long time. We've been doing great things in the off-grid space. So what we have now, maybe I can share my screen if you allow me to do so.
Please do, please do.
Okay. So can you see it?
Yes, thank you.
Okay. Okay. So we put all the things together in one single unit that is called off-grid box. It lies a little bit among the low-tech and the high-tech solutions. So it's simple and robust as a low-tech solution, but also can power with clean energy and clean water and connectivity very well, I'd say, advanced buildings. So it's an affordable clean water and renewable energy unit for remote areas, off-the-grid areas. My name is Emiliano Cecchini, and I'm CEO of this company that is based in Boston in the United States, but the manufacturing site is in Tuscany, in Italy. So basically what we have is the smallest container. It's 2 meters by 2 meters by 2 meters with the solar panels on the top and the water purification technology inside. It can go from 3 to 8 kilowatt. We have a double version with ultra dense PERC solar modules that goes up to 13 kilowatt peak with a 3-phase 20 kilowatt inverter. The storage can go up to 50 kilowatt hours, and it can purify by microfiltration and ultraviolet sterilization up to 20,000 liters a day in its basic setup. It's really easy to set up. It takes like 3 hours. So in the picture here, you see the setup in Puerto Rico right after the typhoon a few years ago. And it has a a business model. So it's not just a piece of tech, it's also a way to engage with local communities. So we deployed in 12 countries now with UNDP, with big corporations that do some corporate social responsibility projects. And we provide the water, pumping up the water from wells, desalinating seawater to convert seawater or brackish water into drinkable water. We do provide electricity in a way that I will show you in a minute, and we also share the Wi-Fi, because to control this unit from remote, we need a satellite connection or even a 3G normal connection. So we pay that connection and we can share it with the local community that can access to the internet as well. It is also a very useful tool for disaster relief or disaster preparedness. So we use it in a bunch of applications through our headquarters in Kigali, in Rwanda, where we serve the Eastern Africa. So we installed in DRC, in Tanzania, in Somalia, Rwanda, and the like. As a key infrastructure, it goes somewhere between the lack of access to electricity, the lack of access, save water, and somehow improve sanitation. During the COVID emergency, we set up those kiosks with this purified water, sterilized water by means of UV ultraviolet lamps, and it helped a lot in preventing the spread of the virus. It's something that can be transported easily with a small truck and easily set up a community hub. So this is the example in Tanzania. Same here, where it's more a double model that can also serve the community while pumping up to 40,000 liters a day from a borehole. The borehole you see here on the bottom left, at least on my screen. And this is helpful for irrigation and watering purposes. If not powering an irrigation system, it can power a building. We just won a tender with USAID in Rwanda for 6 clinics, so it can power a clinic. Or it can power some productive uses as welding machines, milk chilling, agriculture tools like sorting of palm dates, as we do in Somalia, and the packaging, the dryers for the fruit, and a bunch of other things. So this is the double version. This is the installation we did on the Victoria Lake, where the challenge there is to purify water from heavy metals and some salts, because it's kind of salty water, and pollutants as well. So this island here is called Sozia, and now is powered by this machine here that actually has been the largest hardware, I'd say, tool that it's ever brought to the island. This is in the Philippines, the reverse osmosis add-on that fits inside the 2 by 2 by 2 meters container, and in the Philippines it is providing purified water and drinkable water to an island. This is an example in Italy on the Alps. This box has been delivered by helicopter. You can see the videos on YouTube, and it's basically converting an off-grid cabin with no water management system and no power supply in a few hours in a building that has clean water and clean power. We in Rwanda also have a special business model to attend the box and make sure that it is maintained and run properly for a long time, with a 20 years lifespan of a box. So we basically provide 400 families with a small jerrycan, 5 liters, and a power bank, a lithium power bank, and 3 LED lights and phone adapters. So this family can go back and forth from home to the off-grid box, make a micro payment, most of the time a mobile micro payment on their mobile phone, and they can recharge the power bank and refill the jerry can. And this way, with no cost for infrastructure, we can immediately reach 400 families, some 2,000 people, and we do this hiring only women, which is a very strong point for women entrepreneurship and empowerment. So this is basically the kit. You see the power bank, and these are the racks that can recharge these power banks at the off-grid box. The Wi-Fi has a captive portal, very strong speed, and people can connect to the Wi-Fi using this. This is the training of the women to enable them to serve the local community. That's the brand we do, and we involve 40 shops per box selling. Right now, we just sell the purified water. In the future, we might be able to sell other goods, but we are still interacting with hundreds of these small rural shops. For disaster relief, this is an installation we did in the British Virgin Island. The whole island has been swept by a hurricane, and resources were low, and especially skilled and talented electricians were lacking at the very beginning. I have no idea right now, but in the aftermath, there was no one able to repair and provide power to this school. And the off-grid box has been the only quick and reliable source of power. Yeah, this is another installation in Tuscany where mitigation can be used as a way to integrate better in the ecosystem, the off-grid box. So if you have any question, we would love to interact with you. These are my contact details. Feel free to reach out now or later on, whenever you want. Thank you so much.
Thank you very much. That was wonderful. Thank you, Irene. Thank you, Emiliano. I would like to open the floor now to questions for the presenters. This is a great opportunity. We've learned a great deal, and thank you very much.
You're welcome.
Raise your hand, or there is a chat. I will be informed. If not, I would like to start. Is there a question coming? If not, my first question then would go to Irene. When did you realize that you would be an architect and that your mission will be sustainability?
Well, that's quite a hard question. So I wouldn't know when I just understood I would be an architect. I would just very interesting in building, not only in the way they look, but also in the way they're made, in the way they behave. And actually, I was extremely interested in having buildings that can actually work without harming our planet. So I don't know when it started actually, but then I found this school, which is the Architectural Association, which has a very strong master in sustainable environmental design. And I decided to challenge myself. It's a very hard one. And it's also a school that is very hard to get into. And actually, I got more and more passionate about the topic as I was studying and knowing more about it, because it's something that we actually really struggle to understand. So it looks like something that it can be solved by adding a few energy sources that are clean, but it's not all. It's about conceiving the building that is actually responsive to climate, and it starts being responsive in the moment you decide what's its orientation, how it's made, what's its, I don't know, volume to surface ratio. There's a lot of things that can help in a way that like people don't even imagine before starting to understand how energy should be produced, because that's a lot of energy that should not be produced, because it's the building itself that, through adapting to climate, can actually thrive in any climatic conditions. There are some that are more challenging than others, definitely, but that's really something that architects should be more involved in, like at the concept stage, should already start thinking in this prospect, let's say.
Thank you. Emiliano, if it's okay, if I can come back, can you touch a little bit on the logistical or the cost of setting up one of those units? And I want to say that I have many questions, but I don't want to dominate the conversation. How do you set up one of those units? How much would it cost? Your microphone is muted. Emiliano, your microphone is muted.
Sorry again, my bad.
Yes.
So right now, in our experience, we install, train and start the box and train women to attend the box for $25,000 turnkey. So that's a full integrated, all-inclusive solution. The unit costs less than that, but the problem is that you have to incorporate a lot of support. So usually we also look for local entrepreneurs that are interested in getting 80% of the revenues that the box is providing. Is estimated around $10,000 a year, even though in the most cases we are at 60% of this in Rwanda. At capacity, it can produce $10,000 a year, according to Rwandan prices for water and power. So the local entrepreneur can get this 80%, and for 20% keep a mode using all the probes and the monitoring system that is included in the unit. In this way, we can scale while retaining the impact, the positive impact, and promoting local skills and local entrepreneurship.
That is wonderful. Does anybody have a question? I am very curious about the system. And how did you, oh, I see a hand up. Miss Patricia Theron, please go ahead.
Hello. Yes, my question is for Irene. Firstly, thank you for the presentation. It's a really beautiful series of spaces and designs that you showed. You began with mention of how COVID is changing the way we might inhabit spaces. And I wanted to ask you whether you think that there are strategies that we can learn from plants to design spaces differently, considering that plants have evolved immunological strategies that we might consider for future ways of living.
Hello, thanks for the question. There definitely are. So if you think, I haven't been too much in depth with the whole, study that we've been carrying out about plants, but there's a lot of problems that they have demonstrated to be actually able to solve in a lapse of time that is even shorter than what we as human beings would take. So, for instance, something that is striking to me is how in very dense woods, for instance, the trees just set one next to the other to allow for the optimal amount of daylight to penetrate and heat their own roots. So I think you should Google them, but I have a few pictures I can share later probably. You see how they just draw these very incredible patterns of openings in between one tree and the other. so that they can get the optimal distance of their trunks, for instance, and branches. So if we're speaking about distance, if we're speaking about a world in which interaction, human interaction, is not going to be the same as before, in which spaces are going to be conceived in a fully new way, because being stuck in our houses and places has taught us a lot of things and has allowed people to reflect upon how they would like their place to be. What are they missing nowadays? So people living in very small places have dreamt about even also having a small balcony, for instance, about having some breakout space outside, protected yet outdoor space. So I think there's a lot, if we take a look at how plants are distanced to, touch upon a very, let's say, trivial problem of this pandemic. I think there's a lot of research we can carry out, starting with a starting point from how they have solved such problems, because it's not only about a matter of letting light penetrate. It's also about how much distance should be left between one and the other to allow each one of the two to have access to water, for instance, through their roots. So it's kind of, endless knowledge that it's something that we cannot any longer ignore, I believe.
Thank you. I have another question for you, Emiliano. Why United States manufacturing in Italy? How did you get there? And then to you, Irene, how did you discover how did your firm discover the African market when so few is known? I'm very curious. This is just fascinating to me. Thank you. Either one of you can go.
Ladies first.
Thank you. The lady first, yes.
Ladies first. So actually, they were two, so the Posts and Telecommunication project and another one, and the Berngir University campus were entries for competitions. So we just took part to some competition. There's another one for an hospital that unfortunately we didn't win. So we just took part to the competitions because we thought they were very close to our topics, and we won them. And through them, we actually entered a little bit more the African market, so that we had requests for the library, for instance, and so forth. While the last project I showed, the SOS one, the one from the School of Sustainability that is embedded in our firm, was like we wanted to, put the knowledge of the school at the service of a non-profit project. That's something we really do. So also have another one that we have developed for the African context. Of course, I had to make a little bit of selection, but we had more projects. But we believe it's an extremely fascinating and stimulating environment to work with. We're happy to go further, if possible, in the next years.
Go ahead, sir.
Yeah. Do you want me to go ahead?
Yes, the lady has answered. It is how you discover the African market, and there is a lot of science in your project. And also, this is like the first question I asked. How did you know that this would be where you want to go? And then your plant is in Italy and your office is in United States. Can you please share with us? We have students who are listening here and are modeling themselves after you.
Sure. Yeah, I'm Italian and I lived in Italy, and I have a physics background with a PhD in chemistry. And we actually started the company in Italy, and we installed even in South Africa, in East London, nearby East London, one of these boxes. And then basically, an accelerator. So if you want to understand how these startups now are growing and thriving in the global market, you have to go through one of these accelerators. So an accelerator means that in 3 months, 4 months, few months, someone will bomb you of information and will guide you with mentors and will bring you to the market, basically. So we went through this TechStars accelerator program in Boston, where there is the MIT, so a lot of MIT and other level of investors, or relationships, or international view, and everything. So Boston for us is the trampoline, I'd say. So the way you can jump higher and see things with a different eye. I think it's compulsory for everybody. Study whatever you want, but if you want to start a startup, you have to go through one of these accelerators, and you have to pick up the right accelerator, not software if you do solar, and not the different industry if you want to do another industry. So try and understand a little bit better what kind of accelerator you need more. Go for that, and then you start doing your startup. Don't do like we did. We tried to do it ourselves for 10 years, and we wasted a lot of time. Let's say that.
All right. Any other questions? Your Excellency, I want to thank you. We are right on time. I want to thank you for this partnership, for reaching out. Irene, I want to thank you for your patience for this presentation. Emiliano, I want to thank you and your team. Ordinarily, this would have been a moment when our school would invite you to a restaurant to sit down, after a snack, after the presentation, the hall, I'm sure, would have been packed. And then we would go to a restaurant and sit down and share drinks. Our workshop has been locked. We've avoided human contact. And as this process went on, we just were stranded. But here there is this human spirit. And so to keep that spirit, we hope we will collaborate. Your Excellency, this I really want to put on the table is something we want to continue to do. Italy and Africa have a long history. Since the Roman times, we are brothers and sisters. And I want to say that in good spirit.